Hello, and welcome back to another episode of Sleep Science Time. It's wonderful to have you here, whether you're a long-time listener or you've just stumbled upon this particular video. Either way, you're in the right place. I need to tell you something rather extraordinary. I know, you probably already heard about it, but I'm going to try and tell this in my own way for you all. As I'm recording this right now, at this very moment, there is an object roughly the size of Manhattan hurtling through our solar system at over 200,000 kilometers per hour. It came from another star system, travelled through the void of interstellar space for possibly billions of years, and it's currently hiding behind the sun where we can't observe it from Earth. And on October 29th, 2025, just days from now, it will reach the single most important point in its entire journey. A moment that has some of the world's leading scientists suggesting we should all, and I quote, take a vacation before then, because who knows what will happen. Now that sounds rather dramatic, doesn't it? Like the setup for a disaster film where Bruce Willis saves us all by drilling into an asteroid. But this isn't Hollywood. This is real. This object exists. It's out there right now. And whether it's a perfectly natural interstellar comet, or something considerably more interesting depends entirely on which scientist you ask. And honestly, that's what makes this so captivating. The object is called 3I Atlas. The 3I means it's the third confirmed interstellar object ever detected passing through our solar system. Atlas is the telescope system that found it back in July 2025. It should be, by all accounts, just another space rock. A frozen chunk of ice and dust that got ejected from some distant planetary system and happened to wander into our cosmic neighbourhood. Except it's not behaving like just another space rock, it's behaving rather oddly. So oddly, in fact, that a Harvard astrophysicist has published an academic paper titled, "Is the Interstellar Object 3I Atlas Alien Technology?" and assigned it a 30 to 40% chance of being artificially constructed. Before we dive in, I'd love to know, where are you listening from tonight? And what brought you to this video? Are you a space enthusiast who's been following this story since July? Did you see the conspiracy theories flooding social media and want to know what's actually happening? Or perhaps you just enjoy falling asleep to the soothing sound of someone explaining potentially civilization-altering cosmic events in the calmest possible way. Leave a comment and let me know. I genuinely love hearing from you, and frankly, if we're all about to make first contact with an alien civilization, it'd be nice to know we went into it as a community, wouldn't it? And if you find yourself enjoying this particular journey into the intersection of legitimate science and spectacular speculation, I'd be grateful if you'd hit that like button and consider subscribing. It helps this channel reach other people who appreciate having their existential crises delivered with a cup of tea and a gentle British accent. For those of you who've been here before, thank you. You keep this little corner of the internet running, and that means everything. It really does. Now, a word of reassurance before we begin. 3I Atlas poses absolutely no threat to Earth. None. Zero. The closest it came to us was back in July at about 270 million kilometers away, which is nearly twice the distance from Earth to the Sun. So if you were worried about an impact scenario, you can let that go right now. We're perfectly safe. The question isn't whether this thing will hit us. The question is what this thing actually is. Tonight, we're going to explore this mystery from every angle. We'll start with the proper science, what we know for certain about this visitor from beyond our solar system. Then we'll examine the anomalies, the strange behaviours that have scientists scratching their heads and writing papers with alien technology in the title. We'll meet the Harvard professor who's staking his reputation on the possibility that this might not be entirely natural. We'll discuss what's happening right now as the object reaches its closest point to the Sun, hidden from our view. And yes, we'll absolutely dive into the conspiracy theories, because the internet has gone absolutely wild over this one, and some of those theories are genuinely entertaining even if they're probably nonsense. The goal here, as always, isn't to keep you awake all night frantically Googling images of interstellar objects and questioning whether humanity is ready for first contact. Though if that does happen, I apologise in advance, but you probably do that anyway, right? The goal is to give your mind something genuinely interesting to contemplate as you drift off, something that sits right at that fascinating boundary between what we know and what we wonder about. Because here's the thing, we genuinely don't know what 3i Atlas is. Not completely, not yet. The data is incomplete, the observations are ongoing, and reasonable scientists are reaching different conclusions. Some say it's definitely a comet with unusual but explainable chemistry. Others say the anomalies are too numerous to dismiss, and a few are willing to publicly entertain the possibility that we might be looking at something that didn't form naturally. And that uncertainty, that genuine scientific mystery unfolding in real time, is rather wonderful, isn't it? We live in an age where we can watch an interstellar visitor pass through our solar system, where we can analyse its chemical composition from millions of kilometres away, where we can have serious academic debates about whether it might be artificial. Whatever the truth turns out to be, we're living through a remarkable moment in human history. So, shall we begin? Let's start at the beginning, on a perfectly ordinary day in July 2025, when a telescope in Chile spotted something that definitely wasn't ordinary at all. Oh, and if you do need to make a drink or put on your pyjamas, then press pause and go and do that now. On July 1st, 2025, a telescope in Rio Hurtado, Chile, captured something unusual in its automated survey of the night sky. The ATLAS system, which stands for Asteroid Terrestrial Impact Last Alert System, is designed to spot potentially dangerous objects that might be heading toward Earth. It's basically a cosmic early warning system, scanning the heavens for anything that might spoil our planetary existence. On this particular night, it found something, but not a threat, something far more interesting. The object was designated A11PL3Z initially, which sounds like a password you'd create after being told your previous 8 passwords weren't secure enough. But within days, as astronomers around the world trained their telescopes on this new discovery, they realized what they were looking at. The object wasn't orbiting the Sun in a nice, closed elliptical path like a proper solar system resident. It was moving on a hyperbolic trajectory, an open-ended path that would take it straight back out into interstellar space after its brief visit to our neighbourhood. By July 2nd, the Minor Planet Center officially designated it 3i Atlas. The I stands for interstellar, making this only the 3rd confirmed interstellar object ever detected by humanity. That's rather extraordinary when you consider that our solar system is presumably being visited by interstellar debris constantly. We're just not very good at spotting it. These objects are small, dark, fast, and they're not sticking around for long. Finding them requires being very lucky, or having very good telescopes pointed at exactly the right bit of sky at exactly the right moment. The first interstellar visitor we confirmed was Oumuamua, discovered in October 2017 by a telescope in Hawaii. Oumuamua, which means scout or messenger in Hawaiian, was peculiar from the start. It was elongated, possibly cigar-shaped, and it showed unexpected acceleration away from the Sun that couldn't be explained by normal cometary outgassing. This led to all sorts of speculation, including suggestions from some scientists that it might have been artificial. Most astronomers concluded it was probably natural but unusual. We'll never know for certain because by the time we realized how strange it was, it had already left the solar system. The second visitor was 2I Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov using a telescope he built himself, which is rather lovely, really. Proof that you don't need $1 billion space agency budget to make cosmic discoveries, just dedication, skill, and presumably a very understanding family who don't mind you spending evenings staring at the sky. Borisov was much more cooperative than Oumuamua. It behaved exactly like a comet should behave. It had a proper tail, it outgassed predictably, its chemistry matched what we'd expect from a comet. It was frankly a bit boring after the drama of Oumuamua, but in science, boring is often reassuring. And then came 3I Atlas, which is neither boring nor particularly reassuring. Let's establish what we know for certain about this object, the facts that aren't in dispute regardless of which theory you favour. First, it's fast, extraordinarily fast. When discovered, 3I Atlas was travelling at roughly 61 kilometers per second relative to the Sun, about 220,000 kilometers per hour. As it approaches the Sun, it's accelerating due to gravitational pull, and at its closest approach, perihelion, it will be moving at approximately 68 kilometers per second. That's about 245,000 kilometers per hour. To put that in perspective, the fastest spacecraft humanity has ever built, the Parker Solar Probe, reaches speeds of about 190,000 kilometers at its closest approach to the Sun. 3I Atlas is naturally moving faster than our best rocket-powered technology. This speed confirms its interstellar origin. Nothing gravitationally bound to our solar system moves that fast. The solar system has an escape velocity, the speed needed to break free of the Sun's gravitational pull, and 3I Atlas exceeds it comfortably. This object came from somewhere else, travelled through the space between stars, and it's just passing through our solar system on its way to somewhere else. Second, it's big. Estimating the size of distant objects is tricky, but observations from the Hubble Space Telescope and other instruments suggest 3I Atlas has a nucleus, the solid icy core, somewhere between 440 meters and 5.6 kilometers in diameter. That's a rather large range, admittedly. The uncertainty comes from not knowing exactly how much of the brightness we're seeing is from the nucleus itself versus the coma, the cloud of gas and dust surrounding it. But even at the lower estimate, this is a substantial object. At the upper estimate, it's absolutely massive, far larger than either Oumuamua or Borisov. If it is at the larger end of that range, we're talking about an object with a mass of approximately 33 billion tons. That's not a pebble. That's a small mountain made of ice and rock, hurtling through space at speeds that would make any sci-fi spaceship jealous. Third, its trajectory is precisely calculable. By tracking its position over multiple observations, astronomers can work out exactly where it's been and where it's going. When you run the math backward, tracing 3I Atlas's path through the galaxy, it came from the general direction of the constellation Cassiopeia. But here's the thing about interstellar space. It's really quite large. Tracing an object's path back over potentially millions or billions of years, accounting for the gravitational influences of every star it passed, becomes increasingly uncertain the further back you go. We know it came from beyond our solar system, but pinpointing which specific star system it originated from is effectively impossible with current data. Running the trajectory forward is more certain. After its close approach to the Sun on October 29th, 3I Atlas will pass relatively close to Venus on November 3rd, come nearest to Earth on December 19th at a very safe distance of 269 million kilometers, then swing past Jupiter on March 16th, 2026. After that, it will leave the solar system entirely, heading back out into interstellar space, never to return. Unless it does something unexpected, which is rather the question we're all wondering about, isn't it? Fourth, it's active. This isn't a cold, dead rock. It's outgassing, releasing gases and dust as it approaches the Sun and heats up. Observations detected this activity remarkably early, back in May 2025, when it was still 6.4 astronomical units from the Sun, that's beyond Jupiter's orbit. Most comets don't become significantly active until they're much closer to the Sun. The fact that 3I Atlas was already outgassing at such a distance suggested its ices are extremely volatile, easily vaporized even by weak sunlight. The Hubble Space Telescope captured beautiful images in July showing 3I Atlas surrounded by a teardrop-shaped cocoon of dust and gas. The James Webb Space Telescope examined it with infrared instruments and detected strong signatures of carbon dioxide, water vapor, and other compounds in the coma. Every major space telescope that could observe it has taken a look, because opportunities to study interstellar objects are vanishingly rare. So that's what we know. It's an interstellar visitor, the third we've confirmed, moving incredibly fast, possibly quite large, definitely active, and currently on a precise trajectory that will take it past the Sun and then back out into the void. Everything I've just described is uncontroversial. These are the facts. Scientists agree on all of this. What they don't agree on is what those facts mean. Because while 3I Atlas does share some characteristics with known comets, it also does several things that no comet has ever done before, and the more we observe it, the more anomalies appear. Not just one strange behavior that might be explained away. Multiple strange behaviors, each individually unusual, that collectively paint a picture of an object that doesn't quite fit any category we have. Right, let's talk about what makes 3I Atlas so deeply unusual, because it would be one thing if this object had a single quirky characteristic. Comets can be eccentric. They're essentially dirty snowballs flying through space. We can forgive them the occasional oddity. But 3I Atlas has 8 distinct anomalies. 8. That's not eccentric. That's practically a personality disorder. A Harvard astrophysicist named A.V. Loeb, who we'll meet properly in the next chapter, has created something called the Loeb scale to rank how likely an object is to be artificial rather than natural. It runs from 0 to 10, where 0 is definitely natural, and 10 is definitely artificial. He's ranked 3I Atlas as a 4. That might not sound dramatic until you realise that most objects in space rank as 0 or 1. A 4 means this has enough anomalies that we should seriously consider alternative explanations. Let's go through these anomalies one by one, because each is fascinating in its own right, and together they form quite a compelling puzzle. Anomaly 1. The trajectory that shouldn't exist. Interstellar objects should arrive from random directions. Our solar system is a tiny speck in a galaxy containing hundreds of billions of stars, each potentially ejecting debris into interstellar space. These objects should come at us from every possible angle, like rain falling on a sphere. Some from above, some from below, most from somewhere in between. Indeed, the first two interstellar visitors followed this pattern. Oumuamua arrived with an orbital inclination of 123 degrees relative to the ecliptic plane, the flat disk where all our planets orbit. Borisov came in at 44 degrees. Both were steeply inclined, coming at our solar system from well above or below the planetary plane. 3I Atlas. It arrived aligned to within 5 degrees of the ecliptic plane. Its trajectory is almost perfectly flat with respect to the orbits of our planets. It's threading through our solar system like it's following a road map, staying within the same general plane as Mercury, Venus, Earth, Mars, and Jupiter. The probability of this happening randomly has been calculated at about 0.2%. That's not impossible. Obviously it happened, so it's possible. But it's the sort of thing that makes astronomers raise their eyebrows and start double-checking their calculations. Why would a natural object preferentially arrive along the ecliptic? There's no good reason. The Milky Way's disk is oriented about 60 degrees off from our solar system's ecliptic plane, so even if objects preferentially came from the galactic disk, they still wouldn't arrive along our ecliptic. The alignment appears to be genuinely anomalous. Anomaly 2. The tail that points the wrong way. Comets develop tails when they approach the sun and start outgassing. Solar radiation pressure pushes dust particles away from the sun, creating the classic tail that always points away from the sun, regardless of which direction the comet is travelling. It's one of the most reliable features of cometary behaviour. The tail points away from the sun. Always. It's basically the cosmic equivalent of gravity making things fall down. You can count on it. Except 3I Atlas developed what's called an anti-tail, a jet of material pointing toward the sun. Now, anti-tails have been observed before in solar system comets, but they're typically optical illusions. When you view a comet from a particular angle, the tail's geometry can make it appear to point sunward when it's really pointing away but curved. Astronomers can usually explain these away with careful geometric modelling. 3I Atlas's anti-tail is not an optical illusion. Multiple observations from different angles confirm that material is actually being ejected toward the sun. This is not how comets are supposed to work. Solar radiation pressure should push material away, not toward the sun. Something else must be driving this behaviour. Some have suggested unusual gas jets on the nucleus's surface. Others point to complex interactions with the solar wind. But the fact remains, this is unprecedented behaviour for a comet at this distance from the sun. Anomaly 3. The size and speed problem. Remember how I mentioned 3I Atlas might be quite large? If it's at the upper end of size estimates, roughly 5 kilometers in diameter, it's about 1,000,000 times more massive than Oumuamua, and about 1,000 times more massive than Borisov, and it's moving faster than both of them were. Here's the problem. Larger objects should be rarer. There are many more small rocks flying around the galaxy than large ones. so the probability of detecting a very large interstellar object before detecting many smaller ones is quite low. Based on statistical models of interstellar object populations, we should have detected roughly 1 million Oumuamua-sized objects before finding one as large as 3I Atlas. But we've only detected 3 interstellar objects total. To find such a large one so early in our survey work is, statistically speaking, rather unlikely. The probability has been estimated at less than 0.1%. Now, there are potential explanations. Perhaps large objects are easier to detect because they're brighter. Perhaps our models of interstellar object populations are wrong. Perhaps we've just been very lucky. But it adds to the growing list of things that don't quite fit expectations. Anomaly 4. The timing that's almost too perfect. Here's where things get particularly interesting. 3I Atlas's trajectory and arrival time are such that it passes remarkably close to 3 planets, Mars, Venus, and Jupiter, while being completely unobservable from Earth during its closest approach to the Sun. On October 3rd, it passed within 29 million kilometers of Mars. On November 3rd, it will pass within 97 million kilometers of Venus. On March 16th, 2026, it will come within 54 million kilometers of Jupiter. And on October 29th, when it reaches perihelion, its closest point to the Sun, it will be in solar conjunction with Earth, meaning the Sun will be directly between us and the object, making it impossible to observe from Earth. If you were to randomly select an interstellar trajectory and arrival time, the probability of getting this close to 3 different planets while being hidden from Earth at the most important moment has been calculated at about 0.005%. That's 5 in 100,000. Again, not impossible, but increasingly suspicious. Why does this matter? Well, we'll discuss this more in later chapters, but if you were designing a spacecraft to visit a solar system, you might want to survey multiple planets. And if you were planning to do something you didn't want the dominant species to observe, hiding behind the Sun would be rather convenient. Anomaly 5. The nickel without iron mystery. This is where things get properly strange. In August 2025, the Very Large Telescope in Chile analysed the spectrum of gases being released by 3I Atlas. They detected strong emission lines of nickel atoms, lots of nickel, about 5 grams per second, and this rate was increasing dramatically as the object approached the Sun. But they detected virtually no iron. This is unprecedented. In natural objects, comets, asteroids, you name it, nickel and iron always appear together. Always. They're formed together in supernova explosions. They travel through space together. They're found in meteorites together. Their relative abundances might vary a bit, but they're never entirely separated. It's like finding hydrogen without oxygen in water. It doesn't happen naturally. The only places we see nickel without iron is in industrially produced nickel alloys. On Earth, we refine nickel and separate it from iron using specialized processes. It often involves nickel tetracarbonyl, a compound that releases pure nickel when exposed to heat or ultraviolet light. Some scientists have suggested that 3I Atlas might naturally contain nickel carbonyl compounds that release nickel preferentially. It's theoretically possible, though it would be the first time we've ever observed such chemistry in a natural space object. Others point out that if you wanted to coat a spacecraft with radiation-resistant material, purified nickel alloys would be an excellent choice. The nickel emissions also showed another peculiarity. They were centrally concentrated around the nucleus rather than spread throughout the coma like typical cometary emissions. This suggests the source is the nucleus itself rather than dust grains dispersed in the coma. Anomaly 6. The bizarre chemistry. The James Webb Space Telescope analysed 3I Atlas's coma in infrared wavelengths and found something remarkable. The gas surrounding the object is 95% carbon dioxide and only 5% water. This is completely backward from what we expect. Comets are supposed to be mostly water ice with some other volatiles mixed in. Water should dominate. But 3I Atlas is essentially a CO2 comet with a bit of water, the highest CO2 to water ratio ever measured in a comet by a substantial margin. This suggests it formed in an extremely cold region, much colder than where our solar system's comets formed, possibly in the outer regions of another star system where carbon dioxide could condense into ice more readily than water. But it's still deeply unusual and not well explained by current models of cometary formation. Anomaly 7. The polarization that breaks the rules. When light reflects off dust particles, it becomes polarized, meaning the light waves align in particular directions. By measuring this polarization, astronomers can learn about the size, shape, and composition of the dust particles. 3I Atlas showed extreme negative polarization, far beyond what's been measured for any known comet, including Borisov. The level of negative polarization is unprecedented, with a probability of less than 1% based on comparison with all previously studied comets. This suggests the dust particles around 3I Atlas have unusual properties, perhaps very large sizes or strange compositions or shapes that don't match typical cometary dust. It's another piece of the puzzle that doesn't quite fit. Anomaly 8. The WOW signal connection. In 1977, a radio telescope in Ohio detected a powerful radio signal from space that lasted 72 seconds. It was so unusual, so clearly artificial looking, though not necessarily from intelligence, that the astronomer reviewing the data wrote "wow" in the margin. The WOW signal has never been explained or repeated, and its origin remains one of astronomy's enduring mysteries. When astronomers traced 3I Atlas's trajectory backward through space, they found that its origin direction aligns to within about 9 degrees of the direction the WOW signal came from. This is almost certainly coincidence. The direction of the WOW signal is known only approximately. 9 degrees is a fairly large angular separation, and there's no reason to expect any connection between a 1977 radio signal and a 2025 interstellar object. But it's the sort of coincidence that makes people wonder, isn't it? Especially when stacked atop 7 other anomalies. So there you have it. 8 separate anomalies, each individually unusual, collectively painting a picture of an object that doesn't behave like any comet we've ever observed. Each anomaly has potential natural explanations, some more convincing than others. But taken together, they create a pattern that has some scientists genuinely puzzled and others willing to publicly entertain hypotheses that would have been dismissed out of hand for any other object. The question becomes, at what point does unusual but natural become so unusual we should consider alternatives? 1 anomaly? 3? 8? Where's the line? Now we need to talk about Avi Loeb, because you can't discuss 3I Atlas without addressing the elephant in the room, or rather the Harvard astrophysicist in the room, who's written an entire academic paper titled is the interstellar object 3I Atlas alien technology. Professor Abraham Avi Loeb is the Frank B. Baird Junior Professor of Science at Harvard University, former chair of Harvard's Astronomy Department, founding director of Harvard's Black Hole Initiative, and director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics. His credentials are impeccable. He's published over 1,000 papers, mentored dozens of PhD students, and served on the President's Council of Advisors on Science and Technology. This is not some fringe character shouting about aliens from his garden shed. This is one of the most accomplished astrophysicists in the world, working at one of the most prestigious universities in existence. And he thinks there's a 30 to 40% chance that 3I Atlas is artificial. Now, Loeb is no stranger to controversy. In 2017, when Oumuamua was discovered and showed that peculiar acceleration away from the Sun, Loeb published a paper suggesting it might be a light sail, a thin reflective sheet pushed by solar radiation, possibly of artificial origin. The astronomy community largely rejected this hypothesis, often quite vocally. Loeb was criticized for sensationalism, for jumping to conclusions, for giving ammunition to conspiracy theorists. Most scientists concluded Oumuamua was probably a comet with unusual outgassing behavior, though they couldn't entirely explain the acceleration. Loeb's response was essentially, why should aliens be the last hypothesis we consider, rather than just another hypothesis to evaluate based on evidence? If we see something behaving unusually, shouldn't we consider all explanations, including artificial origin, rather than bending over backward to force it into natural categories? It's a fair philosophical point, actually. Science is supposed to follow evidence wherever it leads, not dismiss possibilities because they're uncomfortable or sound like science fiction. But there's also the principle of Occam's razor. Prefer the simplest explanation that fits the facts, and alien spacecraft is rarely the simplest explanation. With 3I Atlas, however, Loeb isn't alone in his concerns. While he's certainly the most prominent voice suggesting artificial origin, other scientists have acknowledged the object is genuinely puzzling. Multiple research teams have published papers noting the anomalies. The conversation is happening in peer-reviewed journals, not just on fringe websites. So what exactly is Loeb proposing? In his paper with Adam Hibbard and Adam Krul, published in July 2025 shortly after 3I Atlas was discovered, Loeb outlines several possibilities. The most conservative is that 3I Atlas is simply a very unusual natural comet with chemistry and behavior we don't fully understand yet. This is what most scientists believe, and Loeb acknowledges it's the most likely explanation. But he also presents alternative scenarios worth considering given the anomalies. One possibility is that 3I Atlas is a mothership, a large carrier vessel travelling through the galaxy. At perihelion, when it's closest to the Sun and moving at maximum velocity, it could use something called an Oberth maneuver to alter its trajectory with maximum efficiency. An Oberth maneuver is a real aerospace engineering technique. When a spacecraft is moving fastest, typically at closest approach to a massive body, any thrust it applies changes its kinetic energy more efficiently than at other points in its orbit. It's a way to get the most bang for your fuel buck, basically. If you wanted to slow down and stay in the solar system, or speed up and go elsewhere, or change course significantly, perihelion would be the optimal moment to fire your engines. Here's the interesting bit. 3I Atlas reaches perihelion on October 29, 2025, and from October 21st to early November, it will be in solar conjunction with Earth, meaning the Sun is between us and the object. We cannot observe it from Earth during this period. It will be hidden from our view. Is that suspicious? Well, that depends on your perspective. If you're designing an interstellar mission and you want to perform maneuvers without being observed by the local inhabitants, solar conjunction would be rather convenient timing. If you're a natural comet, it's just coincidence. Loeb suggests another scenario. The mothership continues on its original trajectory, but at perihelion it releases smaller probes, mini spacecraft that use a reverse Oberth maneuver to slow down enough to intercept planets like Earth, Mars, Venus, or Jupiter. Remember those close approaches to multiple planets we discussed in the last chapter? If you were sending probes to explore a solar system, flying past multiple worlds would be an efficient survey strategy. According to the calculations in Loeb's paper, a velocity change of 30 to 40 kilometers per second during October 2025 could bring 3I Atlas, or components released from it, to Earth by late December 2025 or early January 2026. That's achievable with rocket technology we humans possess, so presumably any advanced civilization would find it trivial. Now, before you start building a bunker, Loeb emphasizes repeatedly that this is a low probability scenario. He's not predicting alien arrival. He's saying that given the anomalies, we should monitor carefully to see if anything unexpected happens. We should collect as much data as possible during and after perihelion. We should use scientific instruments to check for unusual behavior rather than dismissing the possibility out of hand. And he's not just theorizing. Loeb has been pushing for concrete observational campaigns. He recommended that NASA's Juno spacecraft, currently orbiting Jupiter, should be used to observe 3I Atlas when it passes Jupiter in March 2026. Juno has instruments that could potentially detect artificial signals, unusual electromagnetic emissions, or other signatures that might indicate technology rather than natural processes. This recommendation was actually supported by US Congresswoman Anna Paulina Luna, who sent a letter to NASA's leadership in July 2025, encouraging them to use Juno to study 3I Atlas. So this conversation has reached political levels, which is either reassuring, people in power are taking it seriously, or concerning. People in power are taking it seriously depending on your perspective. Loeb also leads something called the Galileo Project, a privately funded scientific initiative to search for evidence of extraterrestrial technology. The project operates 3 observatories in Massachusetts, Pennsylvania, and Nevada, equipped with telescopes and instruments designed to detect anomalous objects in Earth's atmosphere and near space. Loeb has stated they'll be monitoring sky activity during and after October 29th to see if anything unusual appears. So what does Loeb actually believe? In numerous interviews throughout September and October 2025, he's been remarkably consistent. When pressed, he says something like, "As of now, 3I Atlas appears most likely to be a natural comet. But the remote possibility of an Oberth maneuver or probe release must be considered seriously as a black swan event with small probability but huge implications for humanity." In one interview on News Nation in October, Loeb stated there's a 30 to 40% chance the object is not fully natural. In another interview he said, "If you want to take a vacation, take it before October 29th, because who knows what will happen." That last quote went viral, naturally. It's the sort of thing that gets people's attention, though one does wonder if Loeb's travel agent is thrilled or horrified by that recommendation. Other scientists in the field have been more skeptical. Many point out that while the anomalies are genuine and worth studying, jumping to alien technology is premature. Every anomaly has potential natural explanations, even if those explanations are incomplete or speculative. The nickel without iron might be unusual chemistry we haven't seen before. The anti-tail might be complex gas dynamics. The trajectory alignment might just be luck. Some of Loeb's colleagues have been more pointed in their criticism, suggesting he's seeking attention or has become too invested in the alien hypothesis after the Oumuamua controversy. Science has ways of being rather catty when it wants to be, and academic disputes can get personal quite quickly. But here's what's undeniable. Loeb has made testable predictions. He's said that if 3I Atlas is artificial, we should see unexpected trajectory changes around perihelion, or the release of smaller objects, or unusual electromagnetic signatures. If none of those things happen, if 3I Atlas behaves exactly like a comet should behave from here on out, then the artificial hypothesis is falsified, and we can file it away as an interesting but incorrect speculation. That's how science is supposed to work. You make hypotheses, you test them, you adjust based on results. Loeb has put his reputation on the line with specific falsifiable claims. That takes courage, or foolishness, or possibly both. Time will tell which. There's also a deeper question here about scientific culture. Should researchers be cautious about proposing radical ideas because they might be wrong and face ridicule? Or should they be willing to explore low-probability hypotheses if the implications are significant enough? If there's even a small chance we're looking at evidence of extraterrestrial intelligence, shouldn't we check thoroughly rather than dismissing it because it seems unlikely? Loeb argues that we're too quick to assume everything in space is natural, that we apply a double standard. Any anomaly is explained away with natural processes, even if those explanations are speculative or incomplete, while artificial explanations are rejected regardless of how well they fit the data. He calls this prejudice against considering technological explanations. His critics argue that extraordinary claims require extraordinary evidence, and we simply don't have enough data yet to justify the alien hypothesis. That science progresses by being conservative and rigorous, not by jumping to dramatic conclusions. Both sides have valid points, really, and we're about to find out who's right. Because October 29th is days away, perihelion is coming. Whatever 3I Atlas is, natural or artificial, it's approaching the most important moment of its journey through our solar system. The moment when, if Loeb is even partially correct, something might happen. What do you think? Is Loeb a maverick scientist willing to follow evidence wherever it leads? Or has he become too attached to the idea of finding alien technology? Is 30 to 40% reasonable odds, or wild speculation? Drop me a comment with your thoughts, 'cause honestly, this is one of those times when reasonable people can disagree, and we won't know who was right until the data comes in. Right, let's talk about what's happening right now, at this very moment, as you're listening to this. Because timing matters quite a lot with this story, and we're living through the most critical period of 3I Atlas's entire journey through our solar system. On October 21st, 2025, just days ago, 3I Atlas reached solar conjunction with Earth. The Sun, from our perspective, moved directly between us and the object. Since then, we haven't been able to observe it from Earth. It's hidden behind the solar glare, invisible to our telescopes, doing whatever it's doing out there completely unobserved by humanity. And it will remain hidden until early November, when it emerges on the other side of the Sun and becomes visible again. On October 29th, 2025, which is imminent as I'm recording this, 3I Atlas will reach perihelion. It will be at its closest point to the Sun, approximately 203 million kilometers away, just inside the orbit of Mars. At this moment, it will be travelling at its maximum velocity, roughly 68 kilometers per second, 245,000 kilometers per hour. The Sun's gravity will be pulling on it with maximum force, and it will be receiving absolutely enormous amounts of solar energy, over 33 gigawatts of power hitting its surface, equivalent to about a third of all the nuclear power generated in the United States. So why does this date matter so much? Why has October 29th become the focus of so much attention, speculation, and frankly, anxiety? Because if 3I Atlas is a natural comet, October 29th should be when it behaves most like a comet. The heat should cause massive outgassing, potentially outbursts where the nucleus suddenly ejects large amounts of material and brightens dramatically. It might even fragment, breaking apart like some comets do when stressed by solar heating and tidal forces. This has happened before with other comets, including the previous interstellar visitor 2I Borisov, which showed signs of fragmentation as it rounded the Sun. We should see increased activity, a brightening coma, possibly a more prominent tail developing, all the hallmarks of a comet being cooked by our star. But if 3I Atlas is something else, if it's artificial or partially artificial, then October 29th represents something entirely different. It represents the optimal moment for an Oberth maneuver. Let me explain why this matters so much from an engineering perspective, because the timing genuinely is suspiciously perfect if you're designing a mission. When a spacecraft is moving at high velocity near a massive body like the Sun, any thrust it applies translates into maximum change in kinetic energy. It's not just about changing speed, it's about changing the total energy of the orbit. Fire your engines when you're moving slowly far from the Sun, and you get relatively little benefit. Fire them at perihelion when you're moving fastest, and the same amount of fuel produces a much larger change in your trajectory. This is basic orbital mechanics, and it's why spacecraft missions to the outer solar system often do close passes by planets to steal velocity through gravitational assists. The principle has been well understood since the 1920s and is named after Hermann Oberth, one of the founding fathers of rocketry and astronautics. Now, if you're an interstellar spacecraft arriving in a new solar system, you have several possible objectives. You might want to survey multiple planets, which 3I Atlas's trajectory conveniently allows. You might want to slow down enough to stay in the system, rather than shooting straight through, which would require a significant velocity change. You might want to deploy smaller probes to various destinations, each needing their own trajectory adjustments. All of these objectives would benefit enormously from an Oberth maneuver at perihelion. You'd want to wait until you're at closest approach, moving fastest, and then make your move. And here's the bit that has people genuinely unsettled. 3I Atlas is reaching perihelion while hidden from Earth observation. We cannot see what it's doing. We cannot monitor for trajectory changes, for object separation, for any unusual behavior. It's the perfect time to do something you don't want observed, assuming you knew or cared that Earth had observational capabilities, which an advanced civilization presumably would. Is this just paranoia? Perhaps. But consider the probabilities we discussed earlier. The chance of 3I Atlas arriving along the ecliptic plane, passing close to multiple planets, and reaching perihelion during solar conjunction is approximately 0.005%. That's 5 in 100,000. So what might actually happen on October 29th if the artificial hypothesis is correct? Let's explore the scenarios that have been proposed, ranging from conservative to rather dramatic. Scenario 1. The mothership continues. In this version, 3I Atlas is a large, possibly ancient interstellar vessel. It's been travelling for millions or billions of years, drifting through the galaxy, perhaps launched by a civilization long extinct. It's not actively controlled, or if it is, the controllers have decided that our solar system isn't sufficiently interesting to warrant stopping. At perihelion, it simply continues along its gravitational trajectory. No maneuver, no change, no drama. It passes the Sun, continues outward, and exits the solar system exactly as predicted. We observe it in November and December. Note that it's still behaving oddly but not doing anything overtly artificial, and file it away as probably natural but weird. This is Loeb's stated most likely scenario. He estimates maybe 60 to 70% probability that nothing unusual happens. Scenario 2. The probe release. This is more interesting. In this scenario, 3I Atlas is indeed a mothership, but rather than changing its own trajectory, it releases smaller objects, mini probes, at perihelion. The mothership itself continues on its original path and exits the solar system, but it leaves behind multiple smaller craft that use reverse Oberth maneuvers to slow down and adjust their trajectories towards specific targets. These probes might be heading for Earth, Mars, Venus, Jupiter, or all of the above. They'd be much smaller than the mothership, harder to detect, possibly employing stealth technology to avoid observation. Their goal might be scientific reconnaissance, gathering data about our solar system and its planets. If there's intelligence behind them, they might be specifically interested in Earth, as the only planet showing obvious signs of technological civilization. According to the calculations in Loeb's paper, a probe released from 3I Atlas at perihelion with a velocity change of 30 to 40 kilometers per second could reach Earth by late December 2025 or early January 2026. That's 2 to 3 months from now. Not distant future, not next year. Potentially by Christmas. The probes might be small, maybe meters across rather than kilometers. They might not be immediately obvious. We might not detect them until they're quite close, if we detect them at all. And their intentions, assuming they have intentions rather than just following pre-programmed instructions, would be entirely unknown. Are they friendly explorers? Neutral observers? Threats? We'd have no way of knowing until they revealed themselves or we detected them with our instruments. Scenario 3. The trajectory change. In this more dramatic version, 3I Atlas itself performs a maneuver at perihelion. Instead of continuing on a hyperbolic path that takes it back out of the solar system, it fires engines, uses some form of propulsion, and changes course. Perhaps it slows down enough to enter a bound orbit around the Sun, staying in our system rather than leaving. Perhaps it changes direction to intercept a specific planet. This would be unambiguous evidence of artificial origin. Natural comets don't change their trajectories except through outgassing, and the forces involved in cometary outgassing produce relatively small, gradual changes, not sudden course corrections. If we observe 3I Atlas in November and its trajectory has changed significantly from predictions, we'd know immediately that something extraordinary occurred behind the Sun. It would be, without exaggeration, the most important discovery in human history. Proof that we're not alone, that other technological civilizations exist, and that one of them has visited our solar system. Scenario 4, the arrival. The most dramatic scenario, the one that has conspiracy theorists absolutely vibrating with excitement, is that 3I Atlas doesn't just pass through our solar system. It comes here deliberately, and it arrives. Perhaps it's been decelerating the entire time, and perihelion is when it makes its final braking maneuver to settle into orbit. Perhaps it's not heading anywhere else after this. Perhaps we are the destination. In this scenario, we might see 3I Atlas emerge from behind the Sun in November, moving much slower than expected, possibly entering orbit around Earth, or settling into a position elsewhere in the inner solar system. We might see it do something overtly artificial, deploy structures, emit signals, or even attempt communication. This is, admittedly, the least likely scenario according to any reasonable assessment, but it's the one that captures imaginations, the one that shows up in headlines, the one that has people both excited and terrified. What are we actually watching for? When 3I Atlas emerges from solar conjunction in early November, astronomers will immediately compare its position and velocity to predictions. Any deviation from the expected trajectory would be significant. They'll also look for changes in brightness that can't be explained by distance and solar heating, separation of the object into multiple components, unusual spectral signatures suggesting artificial materials or energy sources, electromagnetic emissions in radio, infrared, or other wavelengths that wouldn't come from a natural comet, geometric structures or non-random shapes if we can resolve enough detail. Multiple spacecraft are positioned to observe. The European Space Agency's JUICE spacecraft will get a view from its position in space on November 4th. Mars orbiters have already captured images during the October 3rd flyby, though those haven't been publicly released yet, which is causing its own conspiracy theories that we'll discuss in the next chapter. Ground-based telescopes around the world are ready. The Hubble Space Telescope has observing time allocated. The James Webb Space Telescope will continue monitoring. Even radio telescopes will be listening for any signals. The International Asteroid Warning Network has announced a coordinated observing campaign starting November 27th, specifically targeting 3I Atlas to improve tracking accuracy. Some see this as routine science. Others see it as preparation for something they expect might happen. And the Galileo project, Loeb's privately funded initiative, will be scanning Earth's skies for any anomalous objects that might appear if probes were released toward our planet. Here's what makes this moment so remarkable. We're living through it in real time. October 29th isn't some distant date in the future. It's now. It's happening. As you're listening to this, drifting off to sleep, 3I Atlas is either outgassing violently as a normal comet would, or it's doing something else entirely, and we won't know which until it emerges from behind the Sun. There's something rather extraordinary about that uncertainty, isn't there? We're genuinely waiting to see if humanity's first confirmed contact with extraterrestrial technology might happen in the next few weeks, or if we're just watching an unusual but natural comet and getting rather carried away with speculation. Either outcome is significant. Either we've found evidence of alien visitors, which changes everything, or we've learned that even extremely anomalous objects can be natural, which teaches us humility about how much we still have to learn about the universe. Loeb has said, quite reasonably, that we're engaged in a blind date of interstellar proportions. We've observed this visitor from afar, noted its unusual characteristics, but we haven't really met it properly yet. The real introduction happens when it comes back around from behind the sun and we see what it's actually doing. By the time you're hearing this, October 29th might have already passed. The moment might have come and gone, and we might already know, or be starting to know, what happened. Or we might still be waiting for 3I Atlas to emerge, counting down the days until we can observe it again. Either way, we're living through a genuinely historical moment in astronomy, regardless of how it turns out. We're watching an interstellar object at the most critical point of its passage through our solar system, and we're asking questions that previous generations could only dream about. Could this be artificial? Could this be our first contact? What do you think is happening right now behind the sun at this very moment? Is it just cosmic ice and rock sublimating in the solar heat? Or is it something making calculations, adjusting trajectories, deploying systems we can't even imagine? Drop me a comment with your prediction. Let's see who gets it right. Right then, let's discuss what happens when you combine an interstellar object with unusual behavior. A Harvard professor suggesting it might be artificial, perfect timing for conspiracy theories, and the entire internet having access to social media. The result is, predictably, absolute chaos. Within days of 3I Atlas being discovered in July 2025, the conspiracy theories began. By October, as perihelion approached, they'd reached fever pitch. And I do mean fever pitch. The sort of frenzied speculation that makes you wonder if perhaps we should ration internet access during astronomical events. Let's catalogue the major theories, shall we? From the merely speculative to the absolutely barking mad. The European Space Agency whistleblower. On October 21st, 2025, the day of solar conjunction, a supposed European Space Agency insider came forward on social media, claiming to be a space debris engineer or analyst. This alleged whistleblower posted a detailed statement that went immediately viral, racking up hundreds of thousands of views within hours. The core claim, the Fermi Gamma Ray Space Telescope detected a stable signature from 3I Atlas in mid-September that is not attributable to any other space source. According to this person, the object is emitting a constant engine-like sound, suggesting artificial propulsion rather than natural processes. Furthermore, they claim this data was immediately handed over to NASA under a fresh secrecy procedure, with no trace remaining at the European Space Agency. The kicker, their chilling conclusion: something big is about to happen. In December, many home-based observers will see it all. Now, several things about this are suspicious. First, gamma-ray telescopes don't detect sounds, they detect electromagnetic radiation. Second, data sharing between the European Space Agency and NASA is routine and not generally secret. Third, conveniently, all the evidence has been hidden, so we can't verify any of it. And fourth, this appeared on social media, not through any official whistleblowing channels. But did any of that stop the theory from spreading? Absolutely not. Within 48 hours, the post had been screenshot, shared across multiple platforms, discussed in countless Reddit threads, and cited as evidence by conspiracy theorists worldwide. Because nothing spreads quite like a good leak, real or otherwise. The Mars flyby data blackout. When 3i Atlas passed within 29 million kilometers of Mars on October 3rd, multiple spacecraft were perfectly positioned to photograph it. NASA's Mars Reconnaissance Orbiter with its high-resolution camera, European Space Agency's Mars Express, and ExoMars Trace Gas Orbiter, China's Tianwen-1, and the United Arab Emirates Hope Orbiter all should have captured images. And yet, weeks later, no high-resolution images have been publicly released. The only image we've seen is from the European Space Agency's ExoMars Trace Gas Orbiter, showing a fuzzy white dot with a faint coma. Nothing detailed, nothing revealing the actual structure of the object. This silence sparked immediate conspiracy theories. A Reddit thread titled, "The Chinese silence on 3i Atlas is more concerning than NASA's," argued that China would have immediately released images to upstage NASA if this were an ordinary comet. The absence of data from all agencies suggests to conspiracy theorists a coordinated cover-up. The official explanation is far more boring. Data processing takes time, especially when imaging systems designed for photographing a bright planetary surface are trying to capture a faint, distant object. The images may not have shown anything interesting, or they're being analysed before public release, routine bureaucracy rather than sinister conspiracy. But where's the fun in that explanation? Much better to assume international space agencies are hiding evidence of alien spacecraft, isn't it? The International Asteroid Warning Network training exercise. In late October, the International Asteroid Warning Network announced a coordinated observing campaign for 3i Atlas, running from November 27th, 2025 to January 27th, 2026. They called it a planetary defense training exercise focused on improving astrometric measurements of comets. Conspiracy theorists immediately pounced on this. Why announce a training exercise specifically for this object? Why now, right after perihelion? Is this preparation for something they expect to happen? Is training exercise just cover for an actual defensive operation? The official explanation is straightforward. Comets are difficult to track accurately because their coma and tails affect where they appear to be centered. This campaign is using 3i Atlas as a real-world test case to improve techniques. It's legitimate science and practical preparation for future potential threats. But that explanation requires trusting official sources, and conspiracy theorists aren't particularly inclined to do that. Social media posts suggested NASA was secretly bracing for impact, or preparing military response. One viral tweet claimed, "They're not training, they're tracking something they know is coming." The remote viewers. Yes, really. Several people claiming to practice remote viewing, the supposed ability to perceive distant objects through psychic means, have weighed in on 3i Atlas, and their visions are, shall we say, imaginative. One prominent remote viewer posted that 3i Atlas is pulling energy from everywhere around it, glowing intensely bright, and contains tiny microbial life that it plans to drop on Earth during its solar pass. Another claimed to see ancient tech only advanced aliens could build. A third described geometric structures and pulsing lights invisible to telescopes but apparently visible to psychic perception. The scientific value of remote viewing is, let's be diplomatic, contested, as in not supported by any reproducible evidence whatsoever, but it makes for dramatic social media content, and that's apparently what matters. The fake expert quotes. Perhaps inevitably, fake quotes attributed to scientists began circulating. The physicist Michio Kaku was particularly targeted, with viral posts showing his image alongside claims he said 3I Atlas might be an alien probe sent to Earth to conduct reconnaissance, possibly with hostile intent. Fact-checkers investigated and found the image was from an unrelated February 2025 interview, months before 3I Atlas was discovered. Kaku never made any such statement about this object, but the fake quote garnered over 290,000 views before being debunked, and many people never saw the correction. This is how misinformation spreads in the internet age. A dramatic fake quote spreads faster than the truth can catch up, and even after debunking, people remember the exciting claim rather than the boring correction. The biblical prophecy connections. Of course the Bible got dragged into this. Multiple posts claimed 3I Atlas fulfills various end times prophecies, particularly from Revelation. One theory connected it to the great star called Wormwood that falls from heaven. Another suggested its arrival on October 29th, just before Halloween, was symbolically significant. The fact that 3I Atlas isn't falling to Earth, isn't appearing around Halloween from our perspective since it's hidden behind the sun, and doesn't match the descriptions in Revelation hasn't deterred these theories in the slightest. What NASA actually says. NASA has been remarkably patient through all of this. Their official position remains clear and consistent. 3I Atlas is an interstellar comet. It poses no threat to Earth. The closest it came was 270 million kilometers in July, and it won't come closer than that. There is no evidence of artificial origin. The unusual chemistry suggests it formed in a very cold region of another star system. The anomalies are interesting but don't require non-natural explanations. They've published this information on their official website in press releases and through multiple statements to media. But fighting internet conspiracy theories with facts is rather like fighting a forest fire with a water pistol. Technically you're making an effort, but the scale doesn't quite match. The pattern. What's interesting about all these conspiracy theories is they follow predictable patterns. Find ambiguity or missing data. Assume the absence of information means hidden information rather than just slow bureaucracy. Interpret official silence as suspicious rather than routine. Connect unrelated events into a narrative. Ignore simple explanations in favor of dramatic ones. Is it possible space agencies are hiding something? Technically, yes, anything's possible. Is it likely? No. Coordinating a global cover-up across multiple nations, space agencies, and thousands of scientists would be extraordinarily difficult. Someone would leak. Data would get out. The truth would emerge. The more plausible explanation is that we're watching normal science happen in real time, and normal science is slow, careful, and often boring. Data takes time to analyze. Images need processing. Papers require peer review. This doesn't make for exciting social media content, but it's how actual research works. Meanwhile, the internet will continue doing what it does best. Wild speculation, creative theories, and absolutely refusing to wait patiently for actual evidence when dramatic narratives are so much more entertaining. Right, let's bring this back down to earth, metaphorically speaking, and ask the question sensibly. What is Three-Eye Atlas actually? The vast majority of scientists, we're talking well over 90% of astronomers who've studied the data, believe it's a comet. An unusual comet, certainly. A comet that's teaching us new things about interstellar chemistry and formation conditions in other star systems, absolutely, but still fundamentally a natural object made of ice and rock that's behaving oddly because it formed somewhere very different from where our solar system's comets formed. Let's address each anomaly with the most likely natural explanation. The trajectory alignment with the ecliptic. Statistically unlikely, but not impossible. We've only detected 3 interstellar objects total. Our sample size is tiny. Maybe flat trajectories are more common than we think. Or maybe we just got lucky, or rather, unlucky in appearing suspicious. The nickel without iron. This is genuinely puzzling, but scientists have proposed that nickel tetracarbonyl compounds could release nickel preferentially under ultraviolet light. It's never been observed before in nature, but that doesn't mean it can't happen. We're seeing chemistry from another star system that might have very different formation conditions. The anti-tail? Complex gas dynamics, possibly a symmetric outgassing from specific vents on the nucleus surface. Rare, but comets have surprised us before with unusual behaviour. The high CO2 content. It formed in an extremely cold region, possibly the outer edges of a protoplanetary disk around a different star. Water remained frozen solid while CO2 sublimated and recondensed, creating an unusual composition we don't see in our solar system. The size and timing. Selection bias, possibly. Large objects are brighter and easier to detect. Maybe we've missed thousands of smaller interstellar objects and happened to catch this large one. The timing is coincidental. Every anomaly has a potential natural explanation. None requires invoking artificial origin. Occam's razor, the principle that simpler explanations are generally correct, strongly favours the natural comet hypothesis. But here's the thing. While each individual anomaly might be explainable naturally, having 8 of them in one object is what gives people pause. It's the accumulation, not any single feature, that makes Three-Eye Atlas genuinely unusual. And we should be honest. We don't know everything. We don't understand all of cometary chemistry, especially for objects formed in other star systems. We don't know what range of compositions and behaviours are possible. We're learning in real time, which means admitting uncertainty. Science doesn't demand we jump to aliens when we encounter something strange. But it also doesn't demand we dismiss the possibility entirely without investigation. The appropriate response is, collect more data, analyse carefully, consider all hypotheses including unlikely ones, and follow evidence wherever it leads. That's what will happen over the coming months. When Three-Eye Atlas emerges from behind the Sun in November, we'll observe its trajectory. If it's unchanged from predictions, the artificial hypothesis loses support. If it's changed significantly, we'll have our answer rather definitively. The JUICE spacecraft will observe it. Ground telescopes will track it. The Hubble and James Webb telescopes will study its composition. Radio telescopes will listen for any signals. By early 2026, when Juno potentially observes it near Jupiter, we'll have accumulated enough data to be far more certain about what we're looking at. The honest scientific position is probably natural but worth watching carefully. Don't bet your life savings on alien spacecraft, but don't completely dismiss the possibility either. Stay curious, stay critical, wait for evidence. And perhaps most importantly, whether it's ice or intelligence, whether it's a comet or a craft, be grateful we live in a time when we can even ask these questions, when we can detect visitors from other star systems, analyze their composition, debate their nature. That's remarkable progress for a species that only learned to fly a bit over a century ago. By the time you wake up tomorrow, we might know more, or we might still be waiting. Either way, the universe has reminded us that it's stranger and more wonderful than we often remember, and that's worth appreciating, whatever 3i Atlas turns out to be. Well, that brings us to the end. We've journeyed from the discovery of an interstellar visitor through 8 scientific anomalies, met a Harvard professor who thinks there's a decent chance it's alien technology, discussed what might be happening right now behind the sun, and descended into the absolute carnival of internet conspiracy theories. That's quite a lot to process whilst trying to drift off to sleep, and I do apologise if I've made that more challenging rather than easier. But hopefully your mind is now quietly full of interstellar mysteries, Harvard astrophysicists taking career risks, and the genuine cosmic uncertainty of not knowing what's happening out there at this very moment. There's something rather peaceful about big existential questions, right? They make tomorrow's meetings and errands seem wonderfully insignificant by comparison. I want to say a proper thank you for being here tonight. Whether you found this video because you've been following the 3i Atlas story since July, whether the title intrigued you, or whether you're a regular listener who trusts me not to lead you too far astray into the cosmic wilderness, your presence here means everything. Creating these videos, diving deep into fascinating topics, and delivering them in the most soothing way possible, whilst you're trying to sleep, it's become something I genuinely love doing. And knowing that you're out there, scattered across the world, all drifting off to the same strange stories, that's rather special. I'm absolutely dying to know what you think about all of this. Do you believe Avi Loeb's 30 to 40% odds? Do you think we're witnessing humanity's first contact with alien technology? Or are we just watching a very unusual comet and getting rather carried away? Has anything we've discussed tonight changed how you see our place in the universe? Drop me a comment below and let me know your thoughts. I read every single one, and honestly, you're brilliant, really. Now, whether you're still awake or whether you drifted off somewhere around Chapter 3 when we were discussing nickel emissions, I'm going to leave you with some gentle ambient sounds. Something calm and peaceful to ease whatever's left of your consciousness into proper sleep. Let your mind settle. Let go of questions about spacecraft and comets and October 29th, and just rest. Whether 3i Atlas is ice or intelligence, whether it's natural or artificial, whether we wake up tomorrow to news of first contact or just more data showing it's a weird comet, life will go on. Your experiences are real, your thoughts matter, and the universe will still be vast and mysterious and occasionally wonderful, regardless of what this particular visitor turns out to be. Sleep well, dream peacefully, and try not to spend too much time tomorrow scanning the sky for incoming probes. I'll see you all in the next video. Until then, good night.